In this video, we'll learn about how to use the laws of exponents in some examples. First example, 2 cube into 2 square into 2 to the power of 4. Here, the base is the same and the exponents are different. Let's remember that when we need to find the product of terms with the same base and different exponents, we will keep the base as it is and just add the powers. In our case, what we get is 2 to the power of 3 plus 2 plus 4, which is 2 to the power of 9. Next example, a cube into 5 to the power of 2 into a to the power of 4. In this case, we can find that there are two terms with the same base, but one is different. So let's combine the terms with the same base. Here, a to the power of 3 into a to the power of 4 becomes a to the power of 3 plus 4, and we'll keep the 5 square as it is. Simplifying this further gives us 25 a to the power of 7. Next example, 2 cube into 4 cube into 3 cube. Here our base is different but the exponent remains the same. So we'll keep the exponent as it is and multiply the bases as shown here. So we get 2 into 4 into 3, the whole cube, which becomes 24 cube. Next example, 2 square into a square into 3 square. Here again, the exponent is the same, but the bases are different. So multiplying the bases, we get 2 into 3 into a, and we keep the exponent 2 as it is. Now this results in 6a the whole square, which is 6 square into a square, or 36a square. Next example, 4 by 3 the whole square. Now this can be expanded as 4 square by 3 square, which is 16 by 9. Now let's see what happens when we have minus 4 by 3 the whole square. Minus 4 the whole square divided by 3 square. Here minus 4 into minus 4 becomes positive 16. So our final answer again is 16 by 9. But in our next example, we'll see what happens when we have an odd power. 4 by 3 the whole cube is 4 cube by 3 cube, or 64 by 27. But minus 4 by 3 the whole cube, this becomes minus 4 the whole cube by 3 cube. Here, when a negative number is multiplied odd number of times, the negative sign is retained. Minus 4 into minus 4 into minus 4 becomes minus 64. So our final answer is minus 64 by 27. Next, minus 4 by 3 the whole cube into minus 4 by 3 the whole square. In this expression, our base remains the same, minus 4 by 3. So let's keep it as it is and just add the exponents 3 and 2. So what we get is minus 4 by 3 whole to the power of 5, which can be expanded as minus 4 whole to the power of 5 by 3 to the power of 5, which becomes minus 4 to the power of 5 by 3 to the power of 5. Here, the minus is retained because we have an odd power, 5. Next example, 6 to the power of 0. Let's remember that any expression raised to the power of 0 is always 1. So 6 to the power of 0 is 1. Minus 215 to the power of 0 is also 1. 7 by 3 to the power of 0 is also 1. Minus 97 by 328 whole to the power of 0 is also 1. Now let's say we have an expression like this. 7 by 3 whole to the power of 0, the whole raised to 23. Here again, since 7 by 3 whole to the power of 0 is 1, our final answer is 1 to the power 23, which is also 1. What if we have an expression like this? 85 by 12 whole to the power of 23, the whole raised to 0. Here again, whatever our base is, when raised to the power of 0, the answer will always be 1. Next example, a square into a cube becomes a to the power of 2 plus 3 or a to the power of 5. Next, a to the power of 7 divided by a to the power of 4. Here again, the base is the same and the exponents are different. But we have a division. So, we will keep the base as it is and find the difference between the exponents. So, in this case, we get a to the power of 7 minus 4, which is a to the power of 3. Now, let's consider slightly complicated terms. A square b into a cube b square. If you note carefully, in this expression, we multiply a square, b, a cube and b square. And since multiplication is commutative, we can rearrange these terms to get a terms together and b terms together. So that gives us a square into a cube into b square. Now finding the product of a square and a cube, we get a to the power of 2 plus 3. And then multiplying b and b square, we get b to the power of 1 plus 2. So our final answer is a to the power of 5 b cube. Next, let's consider a similar problem that uses division. A to the power of 5 b square divided by a cube b square. For clear understanding, let us arrange the same as a fraction. A to the power of 5 b square by a cube b square. Now this fraction can also be expressed as a to the power of 5 by a cube into b square by b square. Now, since the bases are the same in the first fraction, we can simplify it as a to the power of 5 minus 3. Similarly, the second fraction becomes b to the power of 2 minus 2. Thus we get a square b to the power of 0. Since b to the power of 0 is 1, our final answer is a square. Next example, a to the power of 10 into b to the power of 10. Here the bases are different, but the power remains the same. So keep the exponent as it is and just multiply the bases. ab whole to the power of 10. Using this example, let's see how to solve some exponents involving numbers easily. Let's say we have to find 2 to the power of 8 into 5 to the power of 8. Using our rule, we keep the exponent as it is and just multiply the bases. So what we get here is 2 into 5 whole to the power of 8, which is 10 to the power of 8. And that is nothing but 1 followed by 8 zeros. Now let's say we didn't use this law. What we would do is find out 2 to the power of 8, which is 256, and 5 to the power of 8, which is 390625, and then find the product of these two numbers to finally get the same answer, 1 followed by 8 zeros. So that shows us that using these laws of exponents make our work much more easier. Let's check out another similar example using division. A to the power of 10 by b to the power of 10 is a by b whole to the power of 10. Let's recall that we keep the exponent as it is and just divide the bases. Now let's use the same law to solve 24 to the power of 3 divided by 8 to the power of 3. Now expressing this as a fraction, we get 24 to the power 3 by 8 to the power of 3. And that becomes 24 by 8 whole to the power of 3. 24 by 8 is 3. So 3 cube is 27. Here again, using the law of exponents has saved us a lot of time and effort by avoiding huge calculations. In the following set of examples, we'll include negative exponents as well. A to the power of 5 into a to the power of minus 3. Since we have the same base, we keep it as it is and just add the exponents. So what we get is a to the power of 5 plus minus 3, which is the same as a to the power of 5 minus 3 or a square. Now let's see another method to simplify the same expression. A to the power of 5 into a to the power of minus 3. Here, a to the power of minus 3 can be expressed as 1 by a to the power of 3. So our expression becomes a to the power of 5 into 1 by a to the power of 3, which could also be written as a to the power of 5 by a to the power of 3. Simplifying this further, we get a to the power of 5 minus 3, which is a square again. This shows us that we can solve expressions involving exponents by using the different laws of exponents. And if you use them correctly, you'll end up with the same correct answer. Next example, a to the power of 3 divided by a to the power of minus 4. Let's again try this using two different methods. First method, since we are dealing with division, we will subtract the exponents. A to the power of 3 minus 4. That becomes a to the power of 3 plus 4, which is a to the power of 7. Next method, let's convert the negative exponent into a positive exponent. So that gives us a cube divided by 1 by a to the power of 4. Now let's remember that when we divide by a fraction, you can change the division to multiplication and the following fraction is replaced by its reciprocal. So what we get now is a to the power of 3 into a to the power of 4. Simplifying further, we get a to the power of 3 plus 4, which is a to the power of 7. In our next set of examples, we'll consider two expressions both having negative exponents. A to the power of minus 4 into a to the power of minus 3. Adding the powers, we get a to the power of minus 4 plus minus 3, which becomes a to the power of minus 4 minus 3. And that results in a to the power of minus 7. Next example, a to the power of minus 2 divided by a to the power of minus 5. So here we subtract the exponents. A to the power of minus 2 minus 5, which becomes a to the power of minus 2 plus 5 or a to the power of 3. In our next set of examples, we'll find out how to solve exponents of exponents. First example, 2a to the power of 5 the whole raised to 3. As our first step, we will try to eliminate the parenthesis by splitting the exponent 3 as 2 to the power of 3 into a to the power of 5 the whole raised to 3. In this case, we have the second term as an exponent of an exponent. We solve this by multiplying the two exponents as a to the power of 5 into 3. So that results in 2 cube into a to the power of 5 into 3 or 8 a to the power of 15. Next example, 3 a to the power of 3b the whole raised to 2. First, let us split the exponent 2 to give us 3 square into a cube the whole square into b square. Here again, we have an exponent of an exponent, a cube the whole raised to 2. So we directly multiply the powers 3 and 2. So our final answer becomes 9 a to the power of 6 b square. Now let us further complicate things and try to solve them. 3a square b the whole square into 2a square b square the whole raised to 3. As a first step, we split the exponent 2 and 3. 3a square b the whole square becomes 3 square a to the power of 2 into 2, which is a to the power of 4, into b square. 2a square b square the whole raised to 3 becomes 2 to the power of 3 a to the power of 2 into 3, which is a to the power of 6, into b to the power of 2 into 3, or b to the power of 6. First, let's compute only the coefficient part. So 3 square becomes 9 and 2 cube becomes 8, which results in 9 a to the power of 4 b square into 8 a to the power of 6 b to the power of 6. Now, since multiplication is commutative, we can rearrange the same expression to group and simplify as 9 into 8 into a to the power of 4 into a to the power of 6 into b square into b to the power of 6. So that becomes 72 a to the power of 4 plus 6, which is a to the power of 10, into b to the power of 2 plus 6, which is b to the power of 8. So our final answer is 72 a to the power of 10 b to the power of 8. Next example, 20 a to the power of 4 b to the power of 6 by 4 a cube b to the power of 4. In this case, let us rearrange the fraction to group the terms with the same base together as 20 by 4 into a to the power of 4 by a to the power of 3 into b to the power of 6 by b to the power of 4. 20 by 4 becomes 5. A to the power of 4 by a to the power of 3 becomes a to the power of 4 minus 3. And b to the power of 6 by b to the power of 4 becomes b to the power of 6 minus 4. That simplifies to 5 a to the power of 1 b to the power of 2, which is simply 5a b square. Next example, 6 a to the power of minus 5 b to the power of 6 by 2 a to the power of 2 b to the power of minus 3. Here again, let's group the fraction as 6 by 2 into a to the power of minus 5 by a square into b to the power of 6 by b to the power of minus 3. That results in 3 a to the power of minus 5 minus 2 into b to the power of 6 minus minus 3. Simplifying that further, we get 3 a to the power of minus 7 b to the power of 9. Next example, 2 a square b the whole raised to 3 into minus 3 ab square the whole raised to 3. Now let's try to solve the same example by two different methods. First method, we'll solve 2a square b the whole cube separately and then minus 3 ab square the whole cube separately. After which, we'll simplify and find out the final answer. So let's consider 2a square b the whole cube. Now that becomes 2 to the power of 3 into a to the power of 2 into 3, which is a to the power of 6 into b cube. Next, minus 3 ab square the whole cube becomes minus 3 the whole cube into a cube into b to the power of 2 into 3, which is b to the power of 6. When simplified, we get 8 a to the power of 6 b to the power of 3 into minus 27 a cube b to the power of 6. In our next step, we multiply the coefficients a terms and b terms separately. 8 into minus 27 becomes minus 216. A to the power of 6 into a to the power of 3 becomes a to the power of 6 plus 3. And b to the power of 3 into b to the power of 6 becomes b to the power of 3 plus 6. So our final answer is minus 216 a to the power of 9 b to the power of 9. Now let's try out the same example using another method. Here, since we have the same exponent 3 with two different bases, 2a square b and minus 3ab square, what we do is keep the exponent 3 as it is and multiply the bases. What we would get next is 2a square b into minus 3ab square, the whole raised to 3. In our next step, we multiply the terms 2a square b and minus 3ab square. 2 into minus 3 is minus 6. A square into a becomes a to the power of 2 plus 1. And b into b square becomes b to the power of 1 plus 2. Simplifying that further, we get minus 6 a cube b cube, the whole raised to 3. Now let's split the outer exponent 3. To get minus 6 the whole raised to 3 into a cube the whole raised to 3 into b cube the whole raised to 3, which further becomes minus 216 into a to the power of 3 into 3 b to the power of 3 into 3. And our final answer is minus 216 a to the power of 9 b to the power of 9. This again shows that you can use different laws to simplify exponents and still get the same answer. With that, we come to our final example. 25 a square b to the power of minus 3 by 5 a to the power of minus 4 b square, the whole raised to minus 2. As I already mentioned, the same problem can be solved using different laws of exponents, but we still end up with the same result. One of the methods, I'll explain it here. If you can find out another method, do let me know in the comment section below. As a first step, we solve what's inside the parenthesis. So let's split up the fraction as 25 by 5 into a to the power of 2 by a to the power of minus 4 into b to the power of minus 3 by b square, the whole raised to minus 2. Solving that further, we get 5 a to the power of 2 minus minus 4 b to the power of minus 3 minus 2, the whole raised to minus 2 again, which becomes 5 a to the power of 6 b to the power of minus 5, the whole raised to minus 2. Now, solving the exponent minus 2 will give us 5 to the power of minus 2 into a to the power of 6 whole raised to minus 2 into b to the power of minus 5 whole raised to minus 2. Here, 5 to the power of minus 2 becomes 1 by 5 square. A to the power of 6 whole to the power of minus 2 becomes a to the power of 6 into minus 2, which is a to the power of minus 12. And b to the power of minus 5 whole to the power of minus 2 will become b to the power of minus 5 into minus 2, which is b to the power of 10. Simplifying further, we get 1 by 25 into 1 by a to the power of 12 into b to the power of 10. Solving further, we get our final answer of b to the power of 10 by 25 a to the power of 12. With that, we come to the end of the video. If you are unable to solve any specific problem in exponents, leave them in the comment section below. If you found this video worth learning, give it a like and share it with your friends to help them learn maths the amazing way. Thanks for watching.